Hi, my name is Anurag and I am from cohort Oracle Full Stack Web Development. So today in this video I am going to show my Capstone project, and that is of DSA, data structure and algorithm. So total I am going to explain 5 questions, and these are question number 1 from code bug fixing, question number 6 that is alternative code implementation, 11 logic building, and 16 analyzing code, and 21 worst and best case. So total I have 25 problem, and I have selected one problem from each set. So total I have 5 sets. So let's start. So first here is what each power of 2. So here I have to check if a number is power of 2, if a given number is power of 2 or not. So basically first it is already I have given a sum code, but that was error. In this code there is issue, there is some bug, so I have to fix that. Oh, I am really sorry for any background noise. So yeah, here what the previous code, what here the bug is, actually they were using here and operator. You can see here, and but actually I have fixed what I have used the binary and to check whether the number is power of 2 or not. Here the concept is like if I check the number with his previous number and I apply binary and, then it will result to 0, and if the result is 0, then that number is power of 2. So yeah, this is my approach. So yeah, so now let's move to the question number 6, that is alternate code implementation. So let's go to question number 6. So yeah, here it is question number 6. So here I have to implement alternate coding approach. This approach was already given, and I have to implement other one. So here the problem is I have to find the number is happy number or not. So the number which will be happy number, of which the final result will be 1. And how we will calculating the final, how we will come to 1? By basically squaring the all digit of number and calculating their sum, and then squaring. Okay, so in first approach they were using the slow and fast approach, that I can say tortoise and hare approach. Here what they were doing is first calculating the square sum of slow, and then in fast they were double times calculating the a square, and they were iterating, like if the equals if the slow is equals to fast, then they will return, that will be the false condition where the loop will exit, and if the slow and fast will be not equal, they will keep iterating until the result will be equals to 1. So yeah, and in the second approach what I am doing is I am also calculating the square. Yeah, this is the main, and after that what I am doing is I am storing it in the set, and if the value repeats, then like if the set has found that number, then that where I will return false, and if I didn't find number in the set, and then I will add again. So yeah, this is my approach, and in my approach I can say the yeah, it is taking extra spaces, but here the concept is very easy, and also it is very easy to understand. So yeah, and on previous on solution number 1, which was actually given here, the time complexity is k times log n, and in my time complexity is constant, not I will say constant, it will take maybe less than linear time, but yeah, actually not a constant time, but yeah, second one is more optimized than first one. Okay, so now let's move to question number 11, that is logic building. So yeah, here question number is 11. So in this problem basically I have to find the peak element. The peak element will be which element on which the both side the value should be less than, like here I can see the number 3, here the number 2 is less than 3, and 1 is also less than 3, then our output will be the 3, but actually I don't have to return 3, actually I have to return the index of 3. So the index of 3 is 2. So this is what I have to do. So yeah, what I have applied here is binary search I have applied here, and if the number, like if the current number is like greater than previous and also greater than their next, then I will simply break the loop and return the mid. And if not, then I will if the number is at mid greater, then I will shift the int, and if the number is like in the else case, I will shift the start. So yeah, this is where here I applied binary search to find the peak element. Okay, to find the index peak element. So yeah, this is my logic. And the next one is problem number 16. Here I have to analyze the code. Basically I don't have to write my own code. Basically I just have to analyze and to compare between both traditional and optimized code. So let's see question number 16. So yeah, this is question number 16. Here I have two solutions. The first one is traditional approach and the second one is optimized approach. Okay, so in this problem what I have to do, I have to find the missing number. Already I have given some sets of number like from 0 to n, and there will be some missing number between 0 to n. So in the first approach we are using the set to store the number to store the unique number, and then we are iterating to see if the set consists of number I or not, and if that set is not consisting that I, then we will simply return the I. So yeah, this is the simple approach. This is easy to understand, but yeah, this is not so optimized because we are using extra like a space. In the second one, actually what they were doing is here applying the sorting and also replacing the value. Okay, and after that we are checking in the sorting, and checking in the sorting is linear time. So, and if the number is not found, then we will return the last element. So yeah, here the time complexity is in optimized approach is linear time, and also in the previous traditional the time complexity is linear, but it is taking the extra space complexity. So yeah, second one is more optimized because it is taking constant space complexity. Here it is taking some extra spaces, you can say, because of hash. Okay, so now let's move to the last, and which will be our 21st. And here I have to frame a story, and I have to take two scenarios. First is worst case and second one is best case. So I have taken the two speech map, and basically I am going to use either of one from here. The worst case scenario is actually in both I am using the same approach, but in worst case first I am splitting the given output. Here our output will be given, and I have to frame the story like the noun, verb, the adjective, noun. Actually I have to replace the noun, here the verb, adjective with some their actual like noun value, and the verb and the adjective. Like here the noun, verb and the adjective, after replacing our output will be something like this. The dog chased the cat. We have replaced the noun with dog, verb with chased, and the adjective with big, and again the noun with cat. So we have to do something like this. So in first approach, in worst case, I can say first I am splitting, and then I am declaring empty value, and first I am taking the speech map on the first one, and after that if the first word is an, then we can't keep the like what, we can't keep this adjective like elegant. You know, if the first word is an, we can't keep the adjective something like chased or this. So we have to change the our speech map. So on basis to that I am changing the here a speech map, and then I am iterating. If the word is found in this speech map, then I will replace with the actual value, and then I will on the last I will concatenate. Okay, and then I will return. Here I am also doing the same things, but this code is more readable. How? Here I am actually splitting and then mapping. Here in the instead of for loop I am using the map here, and then in the last I am using join to concatenate the value, to convert it again into the string type. So yeah, that's all, and a very thank you again. So yeah.